welcome again to Astronomy Spotlight. This is for December 2021. And this month on Astronomy Spotlight, we're going to talk about something very interesting and kind of special. It's not an event that's going on in the sky, but it is the James Webb Space Telescope, which is nearing its launch date. NASA originally slated the James Webb Space Telescope to launch on December 18th, but due to some little glitches and an abundance of caution, they are now saying it will launch no earlier than December 22nd. So hopefully by the end of the year, the JWST will successfully launch. It'll be launched by the European Space Agency and their Ariane 5 rocket, which is the most powerful rocket currently available from their site in French Guiana. This was decided way back in 2005. The question of what kind of telescope should succeed the Hubble Space Telescope was asked in the late 1980s, even before Hubble was actually launched. The recommendation was that the telescope should observe in infrared wavelengths and that it should have a primary mirror greater than 4 meters in diameter. And those recommendations were accepted in 1996. The primary mirror consists of 18 hexagonal segments made of beryllium and coated with a very fine microscopic layer of gold, which is ideal for doing infrared observations. The total diameter of the primary mirror is 6.5 meters or 21.5 feet. What I really want to do now is to focus on what Webb is hopefully going to tell us and answer some of the questions, the great questions that we've had for a long period of time. The mission is scheduled to last between 5 and 10 years, so it is not going to be a multi-decades long mission like the Hubble Space Telescope was. And unlike Hubble, it will not observe invisible light and into ultraviolet wavelengths. It is equipped with cameras and instruments to see in near-infrared and mid-infrared wavelengths. It's been described as an improved combination of the Hubble Space Telescope's resolution and sensitivity and the Spitzer Space Telescope, which of course could see in mid-infrared and far infrared wavelengths. With infrared's longer wavelengths, astronomers will be able to see past the dense, cold molecular clouds surrounding new stars and observe any planets or potential planets forming around them. Webb will also study the very first galaxies that formed in the universe after the Big Bang. As the universe expands, light emitted from stars in ultraviolet and, say, visible light gets stretched to the longer infrared wavelengths. This makes Webb ideal for the job of studying the early universe and the formation and evolution of galaxies. It may even reveal the very first exploding stars or supernovas that occurred in the early universe. Webb will use spectroscopy to measure the physical and chemical properties of planetary systems around other stars to gauge the potential for life in these systems, as well as study the moons around other planets in our own solar system for the very same purpose. Looking at an object spectrum can tell us many things about very distant sources, like stars, planets, galaxies, and nebulae. Every element has its own unique spectral pattern, absorbing or emitting only certain lines within an object spectrum. This can reveal how hot an object is, its distance, and of course, its composition. So Webb will have the ability to look for things like water, oxygen, carbon dioxide, etc., on distant exoplanets in search of potential life elsewhere in the universe. It can even study dozens of stars or galaxies simultaneously. Incidentally, the successor of the James Webb Space Telescope is already well under development. It is the Nancy Grace Roman Space Telescope, named after the first woman at NASA to hold an executive position as the chief of astronomy. In fact, she is also often referred to as the mother of Hubble. Now, as new discoveries are made with the James Webb Space Telescope, we will update you right here on Astronomy Spotlight. Also, if you have any questions of an astronomical nature or any suggestions for topics on Astronomy Spotlight, please send them to the email address on your screen. Thank you for watching. My name is Kirk Rosberg. Until next time.